to be applying what we've learned this unit to solve some real-world problems. Number one, the open box. An open box can be made by cutting out squares from the corners of a 9-inch by 12-inch rectangular sheet of cardboard and folding up the sides. Determine the value of x so that the resulting box has maximum volume. So let's start off by labeling our diagram. We know that our rectangle is 9 by 12 inches. And we know that we're cutting out little squares from the edge that are all x length. So we're looking for our maximum volume. So what we want is to find an equation for our volume. So we know that volume of this box is length times width times height. So we're going to have to find what length, width, and height are. So let's start off with our length. Length is the distance from here to here. So this whole thing is 12, and we're taking away two squares that are both a length of x. So this length is just 12 minus 2x. I'm taking away those two boxes. In the same way, my width, if this is 9 and I'm taking away two boxes, again from here to here is now going to be 9 minus 2x. So there's my length, there's my width. For my height, if I'm folding each of these up after I cut it, my height is just going to be x. This is my length, this is my width, and I know that my height is x. So to write my function now, my volume is just length times width times x. So length is 12 minus 2x. Width is 9 minus 2x. And my height is just x. So this is the equation that I'm going to use. From this, I can get a really quick idea of what this graph looks like just by knowing the roots, right? So my roots here are x is equal to, let's start off with this. This gives me a root of 0. If I were to solve 9 minus 2x equals 0, 9 equals 2x divided by 2 on both sides, I would have an x value of 4.5. And 12 minus 2x equals 0 would give me an x value of 6. So you don't have to show your work each time you do this, but these are the values that you would get if you're solving for your roots. So knowing this, it's a degree of 3. So here is 0, 4.5, and 6. It's a degree of 3, so it's odd. And it's positive, so we know it's going to go like this. And each of these is a single root, so we know it's just going to go straight through. So this is a brief sketch of what my graph is going to look like. So because we're talking now about a real thing, we're talking about a box, we know that we only want positive values for x and also only positive volumes. Okay, so the only thing that we care about, so this is different from yesterday's, we're not looking at the whole graph, we're only going to be looking at this part right here. So the section that is going above the x-axis and is positive. So knowing that, I already know that I wanted to go to 4.5. Let's just pick a number a little bit bigger than 4.5 on my x's. So I already know that I want to stop at 5 for my x's. So now let me graph this in my calculator. Before we start, let's label. So this is my x value. My x value in this case represents my height. So we're going to say height in terms of, this is inches. And my y value is v for volume. And volume is measured in inches cubed. So don't forget to label. That's the first thing we should do. Once we're labeled, let's now go to our graph. We're going to go to my calculator, go to y equals, type in 12 minus 2x, in close parentheses, open 9 minus 2x, close parentheses, and x. So everything you've written here, you should put into your calculator. Okay. And so we know we want our x max to be 5, but we still don't know what our y max is. What we're going to use, just like we did yesterday, go to your table, so second graph, go to your table. We're going to use this to figure out what we want our y max to be. So between 0 and 5, what is the biggest number, the biggest y number this goes up to? It goes up to 80. See how it goes up and then back down? So 80 is the biggest number that we can get to. So let's just pick something slightly above 80. I'm just going to use 100. So now if I go to my window, I want my x min to be 0. So in these real world situations, we don't want any negative numbers, so just 0 to 5. My x scale will go up by 1s. And then my y's, I want to go from 0 to 100. And my y scale, I'm going to go up by 20s. So once I have this, you're going to press graph. And we're going to sketch this. Okay, so this is what my graph looks like. Again, we're going to find our important point. So we're going to have to find our max. And our 0 we actually don't need to find because we already know what it is from here. But if you want to find it, you can to make sure you're doing it correctly. Our 0 is going to be 4.5 comma 0 because that's our root, right? So since this is already in factored form, we can find our root using our equation. But let's find our max the way we know how. So second calc, maximum, which is number 4. And we just want to make sure we're on the left side of the maximum. Press enter. Make sure you're on the right side of the maximum. So if you're not absolutely sure, go a little bit farther than you feel like you need to. Press enter again. And we should have a maximum of 1.697, 81.872. Great. So using this, now we can find our domain and range. So our domain is our x's. We're starting at 0, ending at 4.5. Our y's, again, start at 0, and our highest point is the maximum, which gives us a y value of 81.872. And let's answer some questions. What is the maximum volume that can be enclosed? Your volume is your y value, so we're looking for our y value of our max, which is 81.872, and this is in inches cubed. Don't forget units. And now what are the dimensions that will yield the maximum volume? So we're still looking at the max, but in this time we're looking at our x value. So our x value is 1.697. To find our length, width, and height, now we're just using our equations for length, width, and height. So our length is 12 minus 2x. So since our x value is 1.697, that's what we're going to be plugging in there. Our width is going to be 9 minus 2x, so 9 minus 2 times 1.697. And our height is just x, so we already know our height is 1.697. This is in inches. And we can use our calculator to find the rest of this. So we have 12 minus 2 times 1.697. This gives me a value of 8.606 inches. Width is 9 minus 2 times 1.697, which gives me 5.606 inches. And those are my length, width, and height. They're all in inches. Okay, let's go on to number 2 now. So very similar, just a different situation. So now we have a box with a lid. So we have 2 congruent squares which are removed from one end of a rectangular 10-inch by 21-inch piece of cardboard. So again, let's start off by labeling. This side is 10. This side is 21, since this is clearly our longer side. And we're removing 2 congruent squares. So this is my x and my x. And also this long rectangle. So now we're trying to again find our maximum volume. So we're going to start off by again trying to find length, width, and height. So our width in this case is exactly the same because this is 10 and we're taking away these 2 x's. So this is my width. My length is slightly different because see how this is 21? First what we need to do is, because now we have this whole section right here is our lid, we're going to have to cut 21 in half to figure out what it is from here to here. So 21 divided by 2 is 10.5. Yep. So this section is 10.5 from here to here. And 10.5, we're still taking away one box, one little square right here. So this section is actually 10.5 minus x. This is my length. And then just like before, my height is still x, because if you fold this up, this is going to be the section that gets folded up, and that's your height. So let's write this as my function. So v of x, volume is equal to length, 10.5 minus x, times width, 10 minus 2x times height, which is x. There's my equation. So I know that my roots for this function are x is equal to 10.5, half of 10 is 5, and 0. So just like before, I already kind of know, because this is a positive and it's odd, that it's going to go through my points like this. And I only care about this section. So again, this one's going to 5, because this middle point right here is 5. This is 10.5. So if it's going to 5, I know I can stop it maybe a little bit past 5, so let me graph it till 6. And just like before, let's label it. So I know that my x is still equal to my height in inches. I'm still graphing volume, which is inches cubed. And we're going to go into our y equals, and I'll graph our new function. So this is 10.5 minus x, 10 minus 2x, and x. Let's go to our table again to figure out now what our y's should be. So we want to go from 0 to 6. Let's see what our biggest y value is. It's going all the way up to 102. So since it's going all the way up to 102, let's just use 120. And we're going to go back to our window. So for this one, we want to go from 0 to 6 for my max, or my x's, 0 to 6. And then for my y's, I'm going to go from 0 to 120. And I'll still leave it going up by 20s. Okay, let's graph it. Here's my graph. So again, from my roots, I already know that this first root is going to be at 5. So this is 5 comma 0. I'm going to find my maximum, so second calc 4. Go back up here, go to the left bound of your maximum, right bound of your maximum, press enter. You get a maximum of 2.134 and 102.334. And now we can use all these numbers to find the rest of our problem. So domain, our x's, we go from 0 to 5. Range is our y's are going from 0 to our maximum y value, which is 102.334. Both brackets, because these are all closed points. What is the maximum volume? This is our y value of our max, which is 102.334 inches cubed. What dimensions will yield the maximum volume? So now we know our x value is 2.134. We're going to use this to plug back into our equations for length, width, and height. So we know our height is x. So since height is equal to x, we're just going to plug in our x value, so 2.134 inches. Our length in this problem was 10.5 minus x, so 10.5 minus 1.34, which is 10.5 minus 2.134 gives us 8.366 inches. Our width is 10 minus 2 times x. So we have 10 minus 2 times 2.134. And that gives us 5.732 inches. And there are our dimensions, which will give us the maximum volume. Again, all inches, because they're measuring distance. Okay. One last problem. So now we have a package. So a package may be sent by mail only if the sum of its height and the perimeter of the base is not more than 72 inches. Find the dimensions of the box of maximum volume that can be sent if the base of the box is a rectangle with a length equal to 2 times its width. Okay, so we're going to start off by saying our width is x. And our length is 2 times the width, so our length is 2x. The other piece of information we know here is that the sum of its height and the perimeter of the base, it can't be more than 72. So the height plus the perimeter, sum means perimeter, cannot be more than 72, so let's just say it's equal to 72 because we want it to be as big as possible. So the perimeter of my base, if my width is x and my length is 2x, what this means is the other side of this must be x. The other side of this must be 2x. So my perimeter is 2x plus x plus 2x plus x. So I'm just adding together all four of these sides, which gives me 2x plus 1x is 3x, plus another 2x is 5x, plus another x is 6x. So my perimeter of my base is 6x. So I'm going to plug that into this equation. I'm trying to find an equation for my height. So in this case, I'm going to just subtract 6x from both sides. And now I can write my height as 72 minus 6x. So again, since we're finding volume, which is length times width times height, now I have an expression for length, width, and height. So I can put all three of these together for my equation. So v of x equals, length is 2x, width is x, my height is 72 minus 6x. Here's my equation. So let's start off again by labeling our graph. So in this case, x is not height anymore, x is width. So I'm going to label my axis width here. I'm still looking for volume, which is inches cubed. And again, let me find my roots. So my roots here are, I have 0, 0, and 72 minus 6x. So x is equal to 12. So my roots are 0, 0, and 12. So I know that I need it to go all the way to 12, maybe a little bit farther. So let's just say, we'll just go all the way to 14, even though I know it's going to hit at 12. And now let's put this into our calculator. So go to y equals again. We're going to type in our new equation, 2x, x, 72 minus 6x. Let's go to our table. So we know we want to go from 0 all the way up to 14. Let's see the highest point this gets to. So it's going 132, 480. It keeps on going up and up and up until the highest point it reaches is 3072. So 3072. So to make sure it fits 3072, let me just say that my y max is going to be 4000. So something bigger than 3072. And let's go to our window. So we want our x to go from 0 to 14. I'll have my scale go up by 2. My y's are going to go from 0 to 4000. And I'll just go up by 1000s so I can see my tick marks clearly. Let's graph it. And our graph looks like this. So again, we already know because we solved for our roots that our root here, our 0 is going to be 12, 0. But we still need to find our max. So second calc 4, left bound, right bound, enter. We have a max of 8.00000, so let's round it to 8, and then 3072. Great. And again, now that we have this, we can use this to find all of our remaining questions. So domain is our x's. We're going from 0 to 12, brackets. Our range is 0 to 3072, again, brackets. And my maximum volume is your y value for your max, which is 3072 inches cubed. And what dimensions will yield the maximum volume? So now we're looking at our x value for our max, which is 8. And we're going to plug it into all of our length, width, and height expressions. So our length is 2x, so it's going to be 2 times 8, which is 16. Our width is just equal to x, so it's just going to be 8. And our height is 72 minus 6 times x. So 72 minus 6 times 8, which is 72 minus 48, which is 24. So there are my dimensions, and I am done with this problem.